Today we'll continue electrostatic topic, electric forces. This is charges Q. It can be positive or negative charge. It depends on the electrovalence of the atom. In this case, let's say we have two positive charge. So like charges, same charge, it will repel. So plus and plus, it will repel. Minus, negative and negative also will be repelled. Unlike charges, negative and positive, it will attract. Or positive and negative, it will attract. This one is for the electric forces. Okay, Coulomb's law. Give the electric force between 2-point charges. Okay, this is a formula for force. Force equal to Q1 times Q2 divided by R square. R square is a distance between Q1 and Q2. And time K, constant, or K. Next, okay, this is example. Two charges are separated by a distance R and have a force F on each other. From this formula, if R is double, just put 2R here, and then we substitute 2R square as 2R square, it will become 4R square. At the bottom part, we have 4 here. So it looks like it divided by 4. So we can conclude that if R or distance between two charges is double, then F will be quarter of the F. The previous one is R. So when we double the distance, the force will be quarter due to the distance R square. If Q1 is double, let's say we double the Q1 or Q2, Q1, let's say this Q1, we double to become 2Q1. So we just replace 2Q1 here. Look like we can see that F will be double. Okay, F will be 2Q1, Q2 over R square, K. So it double. Then if Q1 and Q2 are double, we just replace 2 here. It will become 4. 2 times 2, 4. And R is half. Now we half of the F. So this R become 1 over 2 R square root. So 1 over 4 means that 4 divided by 1 over 4, it will equal to 16. Just to show the relation between Q and R, between Q. Okay, the relation between Q and R. We can say that Q is proportional, R is inversely proportional. Distance is inversely proportional. When distance is 4, the force will be reduced. When we increase the Q, the force will be increased. The increasing of Q, force will be increased. Increasing the R, force will be reduced. Next is example number 2. Two 40-gram masses are each with charge of 3 microcoulomb, place 50 centimeter apart. Calculate the electric force between them. So it will repel due to same type of particle, both positive, so it will repel. Force equal to Q1 times Q2 divided by R square times K equal to K. Q1 is 3 micro, Q2 is 3 micro, 0.5 meter. Correct. So we get this answer. This is value for K, Q1, Q2, R. So unit is Newton. Unit for force is Newton. Okay, now example number 3. 3 charged objects are placed as shown. Find the net force of the object with the charge of minus 4 coulomb. Okay, this object. Net force. This one is positive, this is negative, this one is negative. So 4 positive and this one is negative. We can say that this object will be attracted. Go here. F. This one is negative and this one is positive. So from this one, they will repel. So they will be F1 is F1 here. Due to different different charge, this one, and be different of this charge and this charge, different. So it will attract. F2 due to a same charge of this one and this one, blue color. So it will repel. So this direction. Find the net forces. Okay, there are two forces, F1 and F2. F1 due to brake color, F2 due to 5 microcoulomb. This one is 20 centimeter, 20 centimeter. So the distance between this one, we can use this triangle, 20 centimeter, means that 20 square plus 20 square root. This one is the distance between minus 5 microcoulomb and minus 4 microcoulomb. F1 equal to K Q1 Q2 over R square. Q1 K is 9 and Q1 is equal to 5 micro. Q2 is 4 micro divided by R square. R is equal to 1 will become 28 cm. 0.28 power of 2. No, this one is 0.28 is distance here. This one is F2 is equal to 2.3 Newton. F2. This F2 equal to 2.3 Newton. Next is F1. F1 is equal to same 5 micro and 4 micro. The distance is 20 cm, so 0.2. This one will be equal to 4.5 Newton. Now we can plot our vector F1 and F2. Okay, F1 is due to positive charge, and our point. Then to the left, 4.5 Newton. This is F1. F2 go down 45 degree. Then we can plot 45 degree. This is F2. F2 is equal to 2.3 Newton. 2.3 Newton, 45 degree. So now we need to do a summation of vector F1 and F2. So to add vector 1 and vector 2, we need to find this vector. The vector is equal to F2 cos theta. Theta is 45 degree, which is equal to 1.6. And also this vector equal to F2 sine theta, sine 45, which is also equal to 1.6. That is, so the summation will become this vector plus this vector plus this vector. So it become 4.5 to the left, 1.6 to the right, means that 4.5 minus 1.6. This one. 4.5 minus 1.6 become 2.9. So 2.9 Newton. This vector. And 1.6 go down. So 1.6 go down. 1.6. Now our net force will be from here to here. Total vector 2.9 vector plus 1.6 vector. So the net force will be here. Total force. Okay, this one is to get the magnitude, we need to do square root 2.9 square plus 1.6 square, which is will be equal to 3.31 Newton. And the angle, this angle theta is equal to tangent inverse 1.6 divided by 2.9, which is equal to 29 degree. The theta is 39 degree. So find the net net force on the object charged minus 45 degree is equal to 3.31 Newton and angle to 29 degree. So the other 29 degree, actually we have to add, this one is 180 degree. So plus 180 will be equal to 209 degree. This is our answer. 3.31 Newton and 209 degree. Electric fields. Okay, what is electric field? Electric field is defined mathematically as a vector field that can be associated with each point in space. Okay, this one is positive charge. So electric field out from the positive charge. This is electric field. Electric field lines. Okay, this one is a negative charge. Electric field go into that charge, negative charge. Electric field is generated by electric charge or by time varying magnet. Okay, this is electric field line. Positive charge. Electric field line, the symbol is E. Okay, let's say we have another charge here, positive charge here, Q1. This one also Q1. Q1 is a Q2. So due to this charge, positive charge, we have two charge, Q1 and Q2. Q2 is positive charge. So what will happen to this Q1? The Q1 will be moved due to same charge. This we call force. Okay, electric field is electric force. Okay, this is electric force per unit charge. Force per unit charge. Mean that force divided by charge is Q. This Q. F equal to K. Okay, this one is Q1, Q2 over R square. Now we know that by definition, E is force per unit charge. So we can get this formula, force per unit charge, E equal to F over Q, in this case Q2. So E will be equal to K Q1 over R square. Divided by Q1, so Q2 can cancel. So this is formula for electric field strength. Electric field strength. That at distance R, okay. For example, is here. What is electric field strength here? We just know the resistance, know the distance. Distance is R. So just using this formula, we can get electric field strength at this location. Electric field due to multi-point charges. Okay, let's say we have multi-point. At point P is here. So they have Q1 and Q2. In this case, we have two charges due to Q1 and E2 is due to Q2. Let me show. Okay, let's say we have two charges, positive. Point P is here. Point P, Q1, Q2. The distance here 6. Distance here 5. Distance here further 5. Okay, 6, 5, 5. So this P will get force from the Q1 and Q2. From Q1, it will go here. From Q2, it will go here. So the net force will be in between. Sorry, not net force. This one is we talking about electric field. So electric field from Q1 will be here. Electric field from Q2 will be here. And the net electric field will be at the center. Total from the Q1 and Q2. This one is from E2. This is E1. So now to find it, we have to find E1. E1 is equal to KQ1 over 5 square. For Q2 also same K Q2 over 5 square. So we can get the total, and then we do vector summation, so we will get the net electric field there. Same as what we did for electric force. This one. Same as this one. However, in our case now is we want to find electric field. Okay, this one we want to find electric field. We do summation of vector. For example, let's say this one is negative. So electric point P. Electric field from Q1 will be this direction, Q1, so electric field E1. Electric field from Q2, we know that for negative, it will attract. E2 will be this direction, E2. The total will be in between, E1 plus E2. So electric field will be this direction, E1 plus E2. Of negative and positive. Positive Q1, negative Q2. This is due to multiple charge. Let's say we have another charge. For example, we charge positive here. So we have to include this E3 and Q3. So Q3 will be, so the direction will be sum here, this direction. So E1 plus E2 plus E3. E3 is electric field from Q3. Let's say we have one more. Let's say we have more here, Q4. So we have to add this Q4. So what happened to this one is we have to do vector summation, vector addition from the Q4 to. Okay, Q4 is the direction, E4. So this one E1 plus E2. So Q4 is here. It will be here, total. E1 plus E2 plus E3 plus E4. E1 plus E2, E1 plus E2, E3 is here, and then the E4 is here, so we just plus E4 is here, parallel this one, parallel with this one. So the total will be here. This one is multiple electric field. Sorry, electric field from multiple charge. Electric flux. Electric flux is the rate of flow of electric field through a given area. This is our electric field. We take this area. Okay, let me do some analogy. Let's say we have a pipe. Then it's water flow. So water flow. This one we call water flow rate. So water flow rate is amount of water out go from that pipe divided by time taken. For example, 10 meter cube, it will take 1 second. So the flow rate is equal to 10 meter square per second. The rate of water, it can flow 10 meter square in 1 second. This is we call water flow rate. Okay, same goes to electric flux. Electric field flow, the area. So area, electric field times this area, E times area, equal to electric flux. This one is area, electric field. Straight one. This is the effective area. So you have to add cos theta here. Cos theta, the effective area is this one, this area. Effective area So the formula time flux will be equal to EA cos theta. Electric field multiplied by the area of the surface projected to a plane perpendicular to the field, called effective area. And we look from here, this is our eye. We look from here, this area, actually the effective one is just perpendicular. Electric potential energy is required to move unit charge between 2 points. Okay, for example, okay, now this is we have charge Q, positive charge. So the electric field will be this. When there's another charge here, so this charge will be have a force Q1, Q2. So Q2 will be a force from Q1. This is electric field. So how to calculate electric field strength here? Electric field strength here is force per unit Q, F over Q. We take this force per unit Q. So we have formula for force is K Q1 divided by R square. This is E here. Okay, flux. At that area, we just take flux equal to E times this area. This is flux, electric flux. Electric potential energy, E1. We want to move E1 from here to here. Let's say E2. Point A to point B. Move here. So this moving we call, they need energy to move from point A to point B. So electric field at point A is equal to this distance. Equal to K Q1 over, let's say this one is R1. R1 square. Okay, E at B is equal to, E2 is equal to, okay, the distance, R2. Q equal to K Q2 over R2 square. We have point A to point B. Force is equal to Q times E. Force, we give force to this. Okay, then we can move from point A to point B. So to move this force, we have to do some work. So let's say we have this length dl. Okay, d work is equal to force times dl, distance. dw, changes of work, equal to F is equal to QE dl. This is just small dl. So total work from A to B, we need to integrate this part. W equal to QE dl. From A to B. This is work done by the external force when we want to move from point A to point B. To move a unit charge, work we have to divide by Q. Means that the potential difference between A and B, VAB is equal to work divided by Q. Equal to Q divided by Q, next become E dl. Then VAB E is equal to KQ1 divided by R square from A to B. E the potential difference between point P1 and P2 equal to, we just integrate our electric field by the distance. Okay, next is line integral of closed counter. So for closed counter means that go to 0. There's no work done. From here to here, and then we do close from B to A to B. So there's no work done. It will become 0. Electric field as function of electric potential. To find E for any charge distribution easily, E equal to a gradient of potential. From Gauss law, number 1 is equal to, we substitute into this equation, we will get this equation. Now we have 2 del, so del 2V equal to rho V divided by epsilon. This is we call Poisson equation. And when equal to 0, it becomes Laplace equation.